All right, so this is for Calculus 2. It's 7.7 in the book, and it's fluid force on a surface that's immersed in some kind of a fluid, liquid, whatever, okay? So for an example here, I want to give you something like, this is like a gate on a canal, okay? So let's say that this is the surface of the ground here, okay? And the canal gate, let's say that the canal is 20 feet deep, and let's say that it's 10 feet wide, okay? And what we want is, we want the force on this gate. So in other words, this is full of water. Let's just say that it's seawater, so that we know that our density here is going to be about 64 pounds per cubic foot, okay? Approximation. So you might think, well, okay, 200 square feet, we have a density, we can figure out the force, but in reality, right, the force up here at the top is zero, and the force down here at the bottom is significantly higher because it's at depth. Yeah, it's like when you dive into the pool, you feel the pressure gets more intense as you go deeper. So what we're going to need to do is we need to cut this plate into rectangles, and then we're going to find the force on each rectangle, and then we're going to add all the rectangles together with an integral, right? Okay, so let's just cut a rectangle in here someplace, a random rectangle. Okay, there's the rectangle. Now, we cannot cut the rectangles vertically, okay? If we cut them vertically, we're going to have a pressure gradient across the rectangle. In other words, the pressure at the top of the rectangle and the bottom of the rectangle is not going to be the same. So we have to cut the rectangles horizontally so that we have constant depth across our rectangle. So since we're going vertically, our depth is vertical, okay? I know everybody likes to call this the y-axis then, right? Okay, that's fine. For now, I'm going to set this as my zero is going to be the ground level, or the surface of the water level here, okay? Let's remember that, this axis is something that we're imposing on this system, right? So we can put this zero, we're free to change it anytime we want to. But for right now, let's try it there. If it makes the problem easy, we'll stick with it. If it starts to cause difficulty, since we're bringing this, we have the option of changing. We don't want to set up an axis that makes the problem difficult. Be careful with that when you're doing the problems in the book. Also, I want my depth to be positive, so this axis is upside down, okay? This is going to be y positive, all right? Okay, so in order to get the force on this rectangle, okay, we need rho times depth, okay, so I'm using that for my depth, and that's going to be times the area, right? Rho we've got, that's going to be 64. Depth, in this case, the way I have my axis set up, notice that the depth of the rectangle here, this is just y, right? So that's just going to be y, and the area of the rectangle, well, the width is constant. The height of my rectangle here, it's very, very, very thin rectangle, right? And it's on the y-axis, so this is going to be dy. So my area is going to be width times height, so that's going to be 10 dy. So, and also y, my depth, right? My depth is going to be between, My depth is going to go, in this case, from 0 to 20. Okay, so now we're ready to set up the integral. Okay, we can set up here the density of my fluid is constant. Now, it's not necessarily going to be constant. If it's not constant, it's going to be a function of depth, or function of something anyway. And we're going to have to put it inside. But in this case, my depth is my density is constant. Okay. Depth is just going to be y. Y is going to go from 0 to 20. And then I have 10 dy, which is my area. 10 is also a constant, so that comes out. And I have dy. You end up with a very, very simple integral, okay? But this is basically how these problems go. Now, what can change? Well, this doesn't have to be 10 feet wide from top to bottom. It could be something like this. Some of the ones in the book, most of the ones in the book have this kind of a thing where you have to replace this 10 with some function of y, okay? And that function is going to give you the width of your rectangle as your depth increases. this is the quickest, most straightforward kind of way I can do this, I think. If you have any questions, okay, send me an email and I'll make another video to answer them.